Hi, welcome to the G Research Open Source Software Outreach Podcast, the Gross Out Podcast. I'm your host, Jay Faulkner, and today I get to talk with Ben Wilson. And I'm really excited about this because I've been talking with a lot of people who kind of work in areas that I'm familiar with or stuff but I'm going to be honest, I don't know a lot about what Databricks does or about that industry that much. So I'm excited to sit here and chat with Ben and learn a little bit. Why don't you go ahead and tell us a little bit about yourself, Ben? Anything about open source software you're affiliated with or have worked on?
Yeah, sure. Hey, everybody. I'm Ben. I work at Databricks, and I'm the tech lead of the AI-OSS ecosystem team, which is kind of a mouthful. But what it basically means is we're the team that are maintainers and creators of projects like MLflow. We also have ownership and maintainer responsibilities for things like Unity Catalog AI, which is an agentic tool calling framework, and a number of other open source packages, all sort of devoted to ML and AI.
Okay, what's kind of the relationship between Databricks and these software projects? Like, it's obvious that y'all do some maintenance work on them, but is there were y'all the ones who created it, or sort of is your business built around it? Can you help me understand that relationship a little bit in more detail?
Yeah, sure. The biggest one that we're known for, of course, MLflow, was created by one of Databricks' founders, Matei Zaharia, and it's 7.5 years ago or something. So we initially created that to solve a business problem, and it was something that Matei was actually struggling with on a pet project of his own. It's like, why is it so hard to keep track of what I'm doing in modeling? I need to organize all of these artifacts that I'm creating, all these training runs that I'm doing. So he built I think it was over a weekend, a very simple experiment tracker that used local file system to just keep track of what he was doing. Then he brought it to the ML team at Databricks and said, hey, I think this is kind of cool. Do you want to test it out? And people's eyes lit up. They're like, we need to actually do something with this. So back then the team was about 7 engineers working on ML, maybe 8. And they just focused on getting the first version of that out. And the decision early on was made to just put that in the open source and see if it resonated with people. So it's kind of how we do a lot of our open source package implementations. We'll release something that we know is it's not really half baked per se, but more of we want to get product market fit and understand, do people actually want this thing? And then build on that, make it better, make it more production scalable, and then integrate it with the Databricks platform.
The thing that's fun about that, even with just an OSS hat on, is that a lot of times you'll have situations, especially in existing open source software, where people will kind of try to bring a solution with a bow on top. They've already written it. It's like, we've been running this in production for 6 months and we finally got legal to approve us, that sort of thing. And it always is like missing something, right? There's like that genericness to it that you seem to miss when you miss out on that community design step. And it seems like maybe by y'all landing on that decision early on with your projects and using the open source market to help you judge your market fit on the business side, that seems like a really good synergy there.
Yeah, definitely. And there's kind of 2 paths that you can have if you're a large established company that is doing open source development. You can either build something in your own product by just talking to your customers. What do you need? What are your pain points? And we're constantly doing that, both engineers and product. General tech lead at Databricks is probably 6 to 10 meetings a week with customers, just asking, like, hey, what are you struggling with? How can we build things that are actually going to solve these problems for you? That's one way to do it. And that works if you already have established product that you can then, improve on. And it might not be something that makes sense to open source or something that's so key, like integrated into your product that in order to open source something, it just would fall flat in the open source community. They're like, yeah, great. Thanks for this tool that only works with an enterprise, production framework. But if you're trying to get into a new market direction and something that you're just like, hey, this isn't out there. Nobody's doing this, but we don't know if this is a good idea. Then start small and, you know, adopt that agile methodology of, iteratively improving, but also talking to people to make sure that you're building what they want.
So you mentioned a couple of times taking these open source software and integrating them into the Databricks platform. Can we talk a little bit about what that platform is? I'm assuming that that's probably proprietary to your company.
Yeah, for sure. So Databricks started with, we actually started as an open source project, Apache Spark. So the founders of Databricks did that while at UC Berkeley. Matei was, built the first iteration of that. And that core team of 6 or 7 people were involved in that in their postdoc research. And that resonated so much with the community. People were like, you should build a company around this. And that company became, hey, we're running open source Spark, but we're giving you a compute environment. Like, we're building a notebook interface for you to use, and we'll manage the backend hardware for you. You don't have to acquire your own VMs and figure out how to deploy Spark in a stable way. And that has morphed into, over the last decade plus, into a unified platform that has a lot of features in it. Everything from ETL pipeline orchestration tools to the ability to do even the most cutting edge stuff right now, which is deploy Gen AI models or interface with foundation models that we host, and everything that goes along with that. So it's another big part of the platform is sort of enterprise grade security, and that's something that is hard to do if you're going to entirely use open source tooling and try to build something at your company to solve all these problems. You need a big dev team to do all that, and it's just a lot of work to get all that up and running. So we offer stuff like Unity Catalog as part of Databricks, and that allows for RBAC control of data to check those boxes on the enterprise security side.
It's interesting because I think it's easy to underestimate the difficulty in running a service, even if you're just hosting for yourself, because there are so many boxes to check. There's, got to manage the hardware. You've got to figure out how your resources are working. Are you just installing Kubernetes and doing stuff on top of that? How many layers in your cloud sandwich you're going to build up? And then all the way down to getting it. And people really just want to get their work done. They want to be able to be an expert in ML or be an expert in Apache Spark or whatever the specific software is, and leave the infrastructure to other folks. And I'm glad for that, because that's why I have a job. But it's kind of neat to see that Databricks has made a successful business model out of that. So like when you sort of look at the open source ecosystem these days, there are definitely a lot of companies that sort of have a similar story to Databricks, of like starting out as an open source piece of software and working through, and then sort of at some point flipping things on their head and shifting more toward a shared source type of model than a true open source. Like, how do y'all see the market playing out for you all like that? Like with Apache being a foundation that owns Spark, it's not like I don't think there's any risk of a similar thing, but can you maybe understand why a company would go that route?
I think the key decision, like why people do that, where they're like, okay, we put something out there in the open source, now we have to create some private fork of it in order to build a bunch of edge features onto it. That's pressure from investors, I think, about why they need to do that. And I think there's a fine line between what it is that you're open sourcing versus, can you build compelling reasons for why somebody would pay for access to something that is otherwise free. And that's the key, is can you solve the biggest pain points in running that open source software? There are plenty of organizations out there that we talk to who might not be using our version of, say, MLflow, for instance. You go and talk to that team, and you're like, hang on, there's like 60 engineers working in support of MLOps. They're more than capable of taking the open source version that we put out there, and they build their own management system for the back end. Like, hey, well, we know how to spin up VMs. We know how to deploy this to Kubernetes. We got this. And that's one of the sorts of target audiences for our open source project. Because a lot of times those people will file PRs to make the open source project better. So everybody wins. It's great. We're not aggressively going after them to say, well, you've got 800 users and, we offer this managed service on the Databricks side that's going to, do this so much better than you can. We don't have those conversations. It's like, how can we work together to make this better for you? And as long as you're, contributing back, we're totally fine with having you as a member of this community.
Yeah, and I think when you work at a product company, it can be too easy to get caught in the echo chamber of your existing customers or your existing model. And having kind of an open source community can almost act as a check to that a little bit as to, is the industry changing and we don't realize it because our perspective's the same, or that sort of thing. And we see that a lot of times in OpenStack, of that you can sort of predict where the industry is going by seeing the sort of features that people get interested in. And you go, oh, well, I guess, advanced networking is going to be a topic coming up soon because we're getting lots of questions about that and things like that. So it's kind of interesting to see like almost that product type of value that can come out of the open source community with that information. So with MLflow, we had a previous guest who was telling us a little bit about MLflow Go. Is that the only case of like trying to enhance MLflow? If it's been around for 7 years, is there anything else up your sleeve for sort of modernizing that platform as it moves forward?
Yeah, we have a number of things. We're focusing right now. Our big thing on the team is preparing for our next major release, which is MLflow 3.0. That's going to be coming. All the features are going to be announced at Data and AI Summit this June. I think it's like June 7th this year. So we're moving towards, it's funny that we were just talking about listening to the open source community as well as our own customers. We were looking for basically talking with people to understand, does this product that we've built actually meet your needs for not only traditional ML and deep learning training cycles, but for Gen AI as well? And it turned out that the traditional people were like, yeah, it's kind of clunky when we're talking about, we have experiments and then we have all these runs, and then within runs we log our artifacts. And it's really hard to analyze that across a bunch of experiments. It's hard to analyze the data that we need to determine a larger scale project that might be composed of 100 experiments. So we started to digest that information and then talk to a bunch of Gen AI users who are like, this doesn't make any sense for what I'm trying to do. It's just another layer of abstraction that we don't really care about, like this concept of runs. So as part of the MLflow 3, the large change that's happening is an information architecture change. So redoing exactly like all of that core concept of what is the actual entity that we care about. So we're going to model-centric instead of run-centric. That might seem kind of silly, but when you look at it, you're like, hang on, I just create a model, which is the thing that I'm trying to train, or my application for Gen AI that I'm building. When everything starts linking to the model, that means all of the data and all of the components of MLflow can all of a sudden have lineage tracking associated with it. Because we no longer have this runs abstraction that's really difficult and non-performant to link things to. We are focusing heavily on modernizing that aspect just by talking to people and asking them, what is it that you don't like about this?
So can you go a little bit deeper into the being model centric versus run centric? Because that sounds a little bit interesting, but I'm not necessarily a machine learning expert. And I think there might be some folks listening who aren't. So when you say lineage tracking, are you talking about something as simple as like tracking performance of that model over time, or what exactly does that boil down to in more basic terms?
The example that would be most comprehensible by everybody and not just data scientists. Think about just deploying an application. So I'm writing some software application that's going to be interfacing with users, and there's data streams associated with that. So Gen AI is all of this. People like to assume that Gen AI is like, oh, I have to be a data scientist or a machine learning engineer to do stuff. Based on our data and interviews, it's something like 80% Gen AI developers are software engineers these days. Because all you're really doing is interfacing with the REST API. You're not building that model. Some company built that model or open source that model. And very few organizations are willing to have their data science team build a bespoke new torch model and then acquire terabytes of data in order to train it and realize that you need to sign up for about $600,000 in GPUs in order to train that thing over a period of 4 months. So super expensive. It's easier to just interface with something that somebody already built because they're usually really good.
It sounds like it maps a lot back to how search engines used to be, right? Like,
Yeah.
you couldn't run your own search engine because just the idea of it was so massive. You could never get all that information, serve it, get it stored, get it indexed. And it's maybe the same way with AI models, right? Of like the model itself has to be built by a larger entity, has to be given to you, and then you can work on the inputs and outputs to that model.
Yeah, you can do like fine tuning of open source models with your own data. Your mileage may vary about how good that's going to be. There are plenty of use cases where that does make a lot of sense. But if you're looking for something that is what most people associate AI these days with, ChatGPT or Anthropic models, these are conversational agents that have a deep context on broad topics, and they can understand human language exceptionally well. With our information architecture change for this app, we're interfacing with, say, OpenAI and GPT 3.0 Mini or something as our model, or LLM. And we want to create an agent that has the ability we can have that LLM interface with tools that we define, like Python functions that this thing can execute. So we handle that part of the application that we're developing. This agent has all of that information baked into it, and we're deploying this as code. It basically says when a user submits a request, this agentic framework is going to take the user's request, add in a prompt to the beginning of it that's based on whatever our configuration is, as well as a list of tool definitions. It's like, hey, you have the ability to call these 40 tools to provide some amount of determinism into this application. As anybody knows who's like interfaced with LLMs over the last couple of years, if they don't know something, they don't typically say, hey, I don't know that, I can't answer it. They just make something up. And for most use cases, when you're just casually chatting with ChatGPT, for instance, it's not super critical that it's always right all the time. And you can kind of detect when it's like, okay, that it made that up. That's not real. But when you're building an application that maybe your customers are going to be using, and it needs to interface with, say, this application is a customer service bot, like an advanced one, and you want it to have the capability of doing something like canceling orders or checking the state of a shipment or making sure that the billing is accurate. It could be anything. So if you don't have tools that it's using to fetch data to answer the question, it'll just start making stuff up. Like, sure, I can cancel that order for you, but nothing happens in the back end, right? So the tool would be, okay, I need a tool that allows me to pull this customer's order history. I need another tool that allows me to cancel or update orders, and another one that tells me about like charges that are pending on the account. So all of that encapsulated, the tools with the access to the LLM would be our agent, would be our model. So when we're doing development flow with MLflow, we would basically say, hey, this application is our model, and we can version that model. We can create 1,000 versions if we want. But each of those iterations are just associated with that core base entity model. Whereas prior to this change, that would be, okay, I'm creating my customer service bot experiment, and then I'm going to create a new run every iteration that I want to do. And within each run is a model. And it becomes that layer of abstraction is super clunky when you're talking about fast iteration development.
Okay. So I'm going to ask you to get out your crystal ball a little bit here. Like, when talking about how Databricks has been around for 7 years, I think that 7 years ago, if anyone had sort of laid out the current state of the AI landscape, especially the tools that are just, available to everyone on the internet these days, it would have been pretty shocking to someone 7 years ago. If you look into your crystal ball and see the new magic in MLflow 3 and all the things that your customers are asking for and that y'all are going to deliver for tools to help them get there, what do you think's coming up in the next 5 years or so that maybe is similarly hard for folks to see coming or anticipate coming who aren't in the industry?
I love speculation questions. this is something that
If
we
I ask
talk about.
ChatGPT, I guarantee you I get a great answer. I have lots of confidence.
This is something that my fellow podcaster and I discuss on our podcast, and we've never come to a consensus. This whole Transformers architecture, back when the first ones came out many years ago, the first BERT model, NLP just grew up. This is getting a little bit better. Those initial models were not good, but they were proving out that technology and how it could be exploited in such a way to be of high quality. And I see in the next year or two, that architecture is going to hit its limits. I think it's already almost there. It's starting to show the cracks. But I think that the innovation is coming up with the stuff that's coming out of research right now, which is new ways of architecting these models and making things that you can bolt onto them that allows for faster information retrieval dynamically, allowing for multimodal agents that are far more sophisticated than what they are right now, where you can bolt on a mixture of experts into a single input framework and have it be actually performant and not what it currently is. If you're curious, you can go and you have a pro account on OpenAI, you can query their latest model that will take quite a while to answer any question, but it'll run through so many iterations and consume a lot of tokens while doing so. But it's approaching the level of human decision making. So each individual answer might not be within the actual chain of things that are happening, might not be perfect, but it's allowing it to acquire the data it needs through sequential operations in such a way that the final answer is something that's this feels like it's well researched and it's presenting all of the data that I need to answer this very tough question. Within the next 5 or 10 years, we're going to start seeing greater improvements in the things that are succeeding right now, where you look at the capabilities of the latest Claude model from Anthropic, how good that is at writing code. It's shocking how intuitive it is. You provide the correct requirements, it's able to create a module that does a job that I would say is equivalent to the capabilities of a senior software engineer. The next step, I think, is much more comprehensive complexity with stuff like code generation, where you can say, I don't need a simple single-page React app that has these 7 features with it. I want you to build the front end and the back end for this thing, or for this particular application that has the following listed 57 required features, and generate all that code for me. And it can actually do it, and it works.
You're kind of bordering on the stuff that gets me a little bit nervous about this. So I'm gonna drive down that road a little bit before we get done. Do you think that there's a potential with tools like that? And I've heard similar things about the latest Claude coding model. Even some of my most skeptical friends are getting it to do amazing things. But it always scares me a little bit that perhaps someone could use an AI to go beyond their grasp, right? What is there a danger of software engineers beginning to write code and software that maybe they don't even understand?
Oh, that ship has sailed. Nothing that I've seen that any of these models are capable of generating that is beyond the understanding of, say, a senior software engineer. There's plenty of stuff that it generates that is beyond a junior engineer. There's tests that I've done where, while working on certain, not major open source packages, but things that we're like, okay, this is going to take me 4 days to write this implementation. It's just this purely optional mode in this tool. And I know what it needs. I know how to write all that, but I just don't have the time. I'm going to prompt Claude. I'm going to provide my spec. And within 30 seconds, I've got code that I have to make maybe 50 edits to. And otherwise, it's pretty good. That's the final state of the PR that I file. I don't typically do that with implementations, though. I like to know, really design what it is that I'm writing. But I use these models all the time for unit tests. I hate writing unit tests. I think they're super important. They're super critical. But the amount of time required to do things like, if you're writing a lot of patch code, where you're like, hey, I have to mock service requests. I can't do integration testing here because this is either expensive or I have an air gap here where my CI is running. I don't allow it to connect to these services. So I got to mock all this stuff. And you look at some unit tests that we have to write. It's like one test is 300 lines long. And in order to have adequate coverage of all these different edge cases, I got to write 200 tests. That's a week of my life spent just doing that. Whereas I can get assistance from Gen AI to be like, I need to test the following things. Here's the source code. I need unit tests that do these things. Write these for me. He gets it right 70% of the time, but that still saves me 4 days of work.
So we ask everyone who comes on the podcast, we all understand, we've been working in open source a while, that it's not usually a straight path from A to B to get where we're going, that there's bumps along the way, there are mountains, there are valleys, bad stuff happens. And we've all had a few gross moments in our open source career where, just a hard problem, you didn't know how you were going to get past it. Do you maybe have a story you can share with us of when you've encountered a gross moment like that and how you managed to overcome it?
Oh boy, do I have some stories. Yeah, probably the worst one that I've ever done was related to what I was just talking about with unit testing. It was when I first started working on MLflow open source. This must have been 4 years ago. So the project had already been around for 4 years, maybe 3.5 years. Fairly well established, used by, I think at that time we were at 150,000 downloads a day on PyPy. So people were using it. And what I needed to do was, because of the integration I was making with another library, we need to now support this different type of input. So on MLflow, when you're going to deploy something to a server or real-time inference, we have something called signature validation. It's like when a user makes a REST request, we need to make sure that what they're passing in is effectively pseudo type check. It's not really a thing in Python really, but it's basically that model that we're serving can only accept data in a certain structure. And if we just pass garbage in, sometimes the underlying infrastructure of that model, that library's exception handling is not the best. So you get these really confusing exceptions, and bubbling that back up to a user through a REST interface is a recipe for disaster. So what we have is validation logic. It's when you log your model, you tell us what type of data you're going to be passing in. Like, is this an array of floats, or is this an array of a map of string to string? We validate whether that is of the correct format. So I added the ability for users to pass in strings as well as a map of string to string that didn't exist before because it was mostly pandas data frame type inputs to traditional ML. And wrote it, merged it. We've released MLflow, and it was 14 hours after we release. It was like 7 o'clock in the morning the next day. We get our first engineering support ticket from a customer who had just happened to install the latest version. Where I'm looking at it, that's weird. That should work. Did some testing locally. Oh no. This allows us basically to do nothing with strings. And there's a bug in the code. And it turned out that every time somebody was deploying a new model to Databricks model serving with this version being out in the wild, it caused deployment to fail. So by about 2 p.m. that day, we found, I think it was almost 100 customers were filing tickets. So it was just this flood of engineering support tickets coming in, created a sub-zero incident for us. So I had to get a fix in to fix the immediate problem, get that released. And then I spent the 2 weeks doing a diagnosis of what went wrong. Within the first couple of hours, I realized that there was no test coverage for that signature validation in MLflow. Nowhere. We had 0 test coverage. It just kind of worked. So people were like, yeah, it looks good. We did some validation. So yeah, learned a lesson there. Never ship code without test coverage. And never assume that because something is in existence that there is test coverage for it.
Yeah, that makes a lot of sense. That sounds rough, but I'm glad you're able to get that fixed up, and I'm glad you're able to be a guest on our podcast this time around. It's been nice to chat with you. I've learned quite a bit about what Databricks does and about sort of how ML and model development works a little bit. Is there anything that you'd like to point our listeners at before we go? Like, you did mention that you had a podcast of your own. Do you want to plug that?
Yeah, we used to have a podcast called Adventures in Machine Learning. We're transitioning over to a new one. We haven't released any episodes of it yet, but that'll be exciting. Check me out on LinkedIn. You can find me, Ben Wilson's Databricks. I'll show up and you'll start getting notifications of where our new podcast is going to be hosted and hear a couple of nerds talk about super low level ML stuff and software engineering.
Yeah, and we'll stay in touch with Ben a little bit behind the curtain. This doesn't get posted the day after we record it, so we'll keep an ear out with Ben, and we'll make sure to have links to all of his things, and maybe if the podcast is launched by then, that in the description here as well. I'm Jay Faulkner on behalf of G Research and Ben Wilson. Thanks for listening. As always, G Research enables me to have these podcasts to talk to great people in open source. I appreciate that. And the big benefit for them is that if you're looking for a job, you can go to gresearch.com/vacancies. They're hiring for all kinds of positions in London and in Dallas in ML and infrastructure, sort of all the way up and down the stack. So if you're looking for work in those areas, please do apply for a job at G Research. They've done great by me. And if you're interested in the ML stuff, you're certainly going to be interested in what we're cooking up. So for now, I'm Jay Faulkner. Thanks for listening.